Hello everyone. In this lecture series, already we finished the nomenclature of alkane, alkene, and alkynes with cyclo also. Today, we are going to discuss about the functional group, IPC nomenclature of functional group. So, functional group is a group of atoms within a molecule that determines its chemical properties and reactivity. So, in today's class, we are going to discuss the first functional group, that is alcohol. Alcohol functional group. Alcohol. The general formula of alcohol, that is ROH. The functional group is OH. So when we'll do the functional group alcohol, we will learn both suffix as well as prefix. Because in case of multifunctional group in a compound or in a molecule, that time we have to consider only one as a main functional group. All other functional groups should be in prefix. Clear? So that which one will be the main functional group? So that time we have to maintain a priority list. With the help of priority list, we will identify the main functional group. So in case of alcohol, that when that functional group as a main functional group, it means suffix. So suffix name will be OL. As a prefix, name will be hydroxy. As a hydroxy. The common name, that is alcohol. Common name. Common name, that is alcohol. So name, what will be the process to write the name? In case of alkane, just remove that E. So here you have to remove E and add OL. That will be alkanol. Alkanol. Clear? Let's see example, then it will be clear. CH3OH. How many numbers of carbon here? Only one carbon. So that basically derivative of alkane, it means methane. So in case of methane, you have to remove E. Remove E and put OL, that methanol. Similarly, CH3CH2OH, that will be ethanol. In case of 3 carbon, that will be propanol. And if there any branching is there, so we have to maintain the same rules. In case of alkane, alkene that already we saw. Now, tell me this example. Okay, what will be the name? So first thing that we have to identify the parent chain. So when we do the functional group, name of the functional group, that functional group should be in the parent chain. You can say here, if you count the number of carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you consider, but there is no functional group. In this chain, there is no functional group. Clear? So that's why this chain will not considered as a parent chain. This will not be parent chain. Okay? So in case of functional group is there, that time we have to consider that functional group in the parent chain. So here parent chain will be 1, 2, 3. If you go left direction, 3, 4, 5, 6. If you go right direction, 4, 5, 6, 7, 8, 9. Total 9 carbon. So that will be the parent chain. That red portion will be the parent chain. Now, this is a branching or substituent. So 1, 2, 3 carbon. So propyl, which position? Third position. And that functional group here, which position? Second position. So what will be the name of this compound? 3-propyl, 3-propyl. Then how many numbers of carbon? Non-3-OL. The third position, sorry, second position. So that will be second. Here, second. 2-OL. This will be the name. So that way we have to write the name of alcohol. When the functional group as OH group present in the terminal, first position, no need to mention the position. Otherwise you have to mention the position. And that OH group should be the lowest number. That numbering you have to start where the OH group will get the lowest number. Clear? Now, next functional group, that is carboxylic acid. So in case of carboxylic acid, carboxylic acid. What is the functional group of carboxylic acid? How to identify which one will be the carboxylic acid? If this carbon double bonded with oxygen and OH group is there, that particular functional group is called acid, carboxylic acid group. So what will be the as a prefix or suffix? As a suffix, it will be oic acid. Oic acid. In case of prefix, it will be carboxy. Carboxy. So how to write the name? Here alkane. You have to remove E minus E and you have to add oic acid. Oic acid. So that will be alkanoic acid. Alkanoic acid. One important thing here, that is this functional group, that carboxylic acid, it will be always in the terminal position. There is no chances to put in the middle. Why? Because this carbon, one carbon, that is total valency 4. Out of 4 valency, already 3 occupied. That basically bonded with functional group. So only 1 remaining. So that's why there is only one chances it will be in the terminal position. So when we write the name of IPC, so no need to mention the position. Let's see one by one example. Here CH3, okay, if we take as a simplest thing, that is basically COOH, here H. What will be the name? Tell. Methanoic acid, because methane, only single carbon. So that methane, you have to remove E, so methanoic acid. And common name will be formic acid. So here name will be methanoic acid. You have to apply same thing. In case of methane, you have to remove E, then oic acid. Second carbon, that will be ethanoic acid, or you can say that is basically acetic acid. CH3COOH, that ethanoic acid. Ethanoic acid, or common name, in case of here, that common name is formic acid. Formic acid is the common name. In case of ethanoic acid, the common name is acetic acid. Acetic acid. And so on. Propanoic acid, butanoic acid, like this. Next functional group, that is aldehyde. In case of aldehyde, the previous functional group we saw carboxylic acid. So carboxylic acid, like this, COOH, here, this portion was the functional group of carboxylic acid. Instead of OH, if you put only hydrogen, that will be the aldehyde. So here also, the aldehyde functional group, always it will be in the terminal position, because this carbon already bonded with 3, 1 to 3. So that's why this aldehyde functional group always in the terminal position. So that here in case of suffix, that will be al. In case of suffix, that will be al. But prefix, in case of prefix, either it will be oxo or formyl or oxo, formyl or oxo. So here alkane, you have to remove E minus E, you have to add Al, that will be alkanal. So the simplest aldehyde OH here, that will be methanol. Then ethanol, propanol, butanol, like this. Now next functional group, that is ketone. In case of aldehyde, already we saw we compared with carboxylic acid. So in carboxylic acid, if we remove OH and just bonded with hydrogen, that becomes aldehyde. In case of ketone, if we compare aldehyde and ketone, next ketone. So in case of aldehyde, CO, here hydrogen, here another atom, it is alkyl group. So if you remove this hydrogen, so here both sided are alkyl group. That functional group, this is your functional group, this is called ketone. It means there is no chances to get that ketone functional group in the terminal position. If you want to satisfy that functional group as a ketone, that C double bond O, that carbon should be attached to alkyl group. So there is no chances to put in the terminal position. So here suffix will be ONE, on. Suffix is ONE, on, and prefix, that will be oxo. Prefix oxo. Similarly here also alkane, you have to remove E and add ONE. It means alkanon. Here another thing, that you have to mention the position of the functional group. So if we see the example, so in case of ketone, what will be the simplest ketone? In case of formaldehyde, we saw single carbon formaldehyde. Sorry, in case of aldehyde, we saw single carbon aldehyde, single carbon carboxylic acid. But here, what will be the simplest ketone? It means lowest number of carbon will get the ketone. So we have to satisfy this condition. C, single carbon, here another CH3, So this will be the simplest ketone, third carbon. In case of, what will be the name in this compound? So that 1, 2, 3, 3 carbon, that is propane. You have to remove E, then ONE, propanone. But you have to mention the position also. So propan, so name will be propan 2 ONE, propan 2 on. Or that common name is acetone. Common name is acetone. Similarly, if we see this example, what will be the name? That will be butane 2 on. 1, 2, 3, 4. So your numbering start from the left side, because that functional group should be the lowest number, lowest position. So here butane 2 ONE. What will be the common name? That common name, that carbon here, one side methyl, another side ethyl. So ethyl methyl ketone, that will be the common name. So that functional group, left side 1 carbon, right side 2 carbon. So this left side is methyl, ethyl. Alphabetically E will be first, so that's why ethyl methyl ketone. So common name here ethyl methyl ketone. Clear? So today's class we covered 4 functional group. First was alcohol, then carboxylic acid, after that aldehyde and ketone. So next class we will see another 4 functional group. Thank you.